Welcome everybody to our webinar on underwater filmmaking. My name is Caitlin Bailey and I'm here with Emily Narrow and Tara Smithee. We are all part of the Global Foundation for Ocean Exploration's video team. We go on to the next one. The Global Foundation for Ocean Exploration, or GFOE, is a nonprofit whose mission is to design, build, operate, and maintain technologies that are specialized in exploring large bodies of water, like the ocean, or places like Yellowstone Lake. As the video team, we share these explorations with the public through videos, photos, and social media. Now, we want to tell you a little bit about our backgrounds. Again, I'm Caitlin Bailey. I live in San Antonio, Texas, and I've always loved animals and the ocean. When I was a kid, I actually wanted to be an animal behaviorist and study marine mammals. I got a Bachelor of Science in animal biology and figured out that research just was not my thing. So I combined my love of art with science and became a science filmmaker. I got a Master of Fine Arts in Science and Natural History Filmmaking from Montana State, and have been working with GFOE and NOAA ship Okeanos Explorer since 2016. Emily?
Hi everybody, thank you so much for joining us today. I also am a member of the video team with the Global Foundation for Ocean Exploration. And I have a bachelor's degree. I double majored actually in biology and in cinema studies. And I got that at Oberlin College. And I also have a Master of Fine Arts degree in Science and Natural History Filmmaking from Montana State University. And I've been sailing with the Global Foundation for Ocean Exploration since 2016. And I actually live in landlocked Bozeman, Montana. And I also had an interest in biology and ecology, but I also was very interested in filmmaking, so I sort of combined those two pursuits, and now I am an underwater filmmaker with GFOE. Tara?
Well, I'm from Portland, Oregon, and I guess my career path started when I had an opportunity to get a master's degree from Stanford University, and I was able to study at Hopkins Marine Science Station and in Monterey, California. And I learned to scuba dive and was able to go to the sea for the first time and work in a lab for a while. And all of that just gave me an absolute love and curiosity for the oceans. And although I did realize I didn't want to be a scientist, and so I had to find something else I wanted to do. Once I graduated, my love of nature and animals and adventure just led me eventually to do an internship on the Okeanos Explorer. And once I met the GFOE team, I just fell in love with what they did and the way they did it. I loved the ship and being at sea, and eventually I was able to join their team. And in order to do that, I went to Montana State University and got a degree in science filmmaking, so I could work as a professional. So that's that. Okay, so now that you all know a little bit more about us, I'd like to introduce the ship to you, and this is where we all work. This is the Okeanos Explorer. The Okeanos is the only ship in the NOAA fleet whose only mission is to explore the ocean. And the NOAA is it stands for the National Oceanic. But has equipment that can create 3D maps of the two robotic the deep ocean. Can you move on? Next slide, please.
Sorry, Tara, you're cutting in and out a little bit.
Oh, strange.
Yeah, so you just want to tell us again quickly about the ship?
Sure, yeah. And then is
let's see here. Sorry, folks, we're gonna try and
yeah, there's some NASA, but am I still cutting out?
Yeah, unfortunately, we're just not getting your audio. You're freezing up. So I'm just gonna quickly give people just a quick overview of the Okeanos. As Tara said before, it's the only ship in the NOAA fleet that's dedicated exclusively to ocean exploration. And Tara knows so much about this ship. She's been sailing on it, I think, the longest of all of us on the video team. And it's really just a great operation. And I'll go in a little bit more into what it is that we do on the ship. Let's see here. So if you can see the slide here, this is sort of a breakdown of the operations that we have. Tara, if you want to maybe try and refresh your connection, maybe drop out and then try and drop back in. I'm just going to keep rolling here.
I'll try that.
Okay. Thank you for everybody for your patience. As you can see on the slide here, hopefully you guys can see this. This is sort of a breakdown of how things work on the ship. So we have a two-body ROV system, and you see down here is the main ROV at the bottom, looking at that beautiful coral, and connected to it is a camera platform, and then that gets connected by a tether. Those two vehicles get connected by a tether to the ship. And those cameras on the ROVs are connecting footage, and that footage is sent up through the cable up to the ship, and then a satellite on the ship then sends that information to a satellite in outer space. And then that information is beamed to anyone around the world who wants to watch it, to scientists and institutions, universities, and you right at home. So when we do ocean exploration on the ship with the ROVs, that footage can be watched live with about a 10-second delay by anyone in the world with internet capabilities. So it's really amazing. You, the public, are able to see something on the bottom of the ocean floor with just a 10-second delay, just see it live. And that's just such an amazing part of our operation. So I mentioned that two-body ROV system, and when we're on the NOAA ship Okeanos Explorer, the ROVs that we're using are Deep Discoverer, which you see being lifted into the water there on the right, and Sirius. And Sirius is named after the brightest star in the sky because it helps provide a lot of light down onto Deep Discoverer in our operations. And, you know, part of the reason we have a two-body ROV system is that, here, I'll actually go back to this former slide here, is that if there's rough seas and a lot of weather, the ship, you know, will be rocking a little bit, and it might even like lose positioning just like by a little bit, which would end up dragging the ROV that's down there, Deep Discoverer. And so the camera platform, Sirius, acts as a little bit of a shock buffer as well. So those are our two ROVs that we use when we're doing our operations on the Okeanos Explorer. It's Deep Discoverer and Sirius. And Deep Discover, it's an amazing vehicle. There are only a few deep rated ROVs in the world. Deep Discover is one of them. It can dive up to 3.7 miles deep in the ocean. That's nearly 20,000 feet deep. We often also do these measurements in kilometers in metric. And so I believe it's rated down to 6,000 meters deep. So 3.7 miles or 6 kilometers, we're talking sort of very, very deep depths of the ocean, obviously way further than anyone can do scuba diving, which I believe the record scuba dive is about 430 meters. So obviously these ROVs are amazing pieces of technology that are built to withstand the intense pressure of the deep ocean and allow us to reach depths and explore depths of the ocean that most people have never seen before. And a big part of that operation is the cameras on the ROVs. So those two vehicles, they're remotely operated vehicles, so ROVs. So they're operated remotely. So there are no passengers on these vehicles. Everyone, all the ROV pilots and the engineers, they're on board the ship, on board the Okeanos Explorer. Everybody stays dry, and the vehicles themselves get sent into the water. And the way that we can see what they see is all of the impressive cameras that are on the vehicles. And right there, you're seeing the arrow pointed to the main ROV camera on Deep Discoverer. And that camera has, I believe, 20 times zoom on it, and it provides probably some of the most beautiful images that we're able to capture and that the public is able to see. So like I said, there are no passengers on the vehicles. They're completely controlled by engineers and pilots on the ship, and that happens in the control room, the mission control room, as you can see right here on board the Okeanos Explorer. And so this is what it looks like in our control room. And so we can see in the front row there, closest to the large time code clock on the wall, that's our front row, and that's where the ROV pilots and engineers operate the vehicles. On the far left, we have a navigator. In the center, we have a pilot who is directly controlling Deep Discoverer. Center right, we have a co-pilot who is controlling Sirius. And then on the far right, we have a video shader who is controlling the cameras on the vehicles. And we'll get into that position in a minute. And then if you see in the back row, we have the three people on the, we have two people on the left and then one person sort of center left. Those are scientists. And they're on headsets and they're talking to the pilots saying, oh, you know, we're looking at a coral right here. Could you move the vehicles up further to go see that fish? You know, oh, look, it looks like there's some interesting geology over there. And they're talking on their headsets to pilot, co-pilot, and video shader to sort of tell them, you know, hey, could you move the ROV over here? Could you move the ROV over here? So they're sort of directing the dive in terms of the content of the dive of what we're exploring, but always in concert with the ROV team. And then the last person on bottom right is a video clipper. That's another member of the video team, and we'll get into those positions shortly. How you doing, Tara?
We'll see. We're gonna try moving locations. We'll see what's better.
Okay.
Yeah.
Anything you wanted to add about the mission control room?
No, I think you covered it.
All right. Thank you very much.
Appreciate it.
Why don't you talk a little bit about the shading station? We'll see how your audio comes through.
For sure. So this here's a close-up view of the shading station. This is where we operate the cameras. If you look at our video team member's hands, he's adjusting the colors and he's based upon the black and white color chart on the screen. He's sort of adjusting the colors to the black-white balance and the black balance to make the image look as realistic as possible. When we get down to the bottom of the ocean, we lose a lot of our, you know, shooting the video through water is very different than shooting it on land. So every dive is a little bit different. So we can move on to the next one. So welcome to the bottom of the ocean. This is where it gets very dark down here. And so in order to film at this depth, we need to bring our own light. The ROV has multiple light arms that we can basically extend and adjust to almost any position we want. And that's critical because light is such an important part of video. It's almost as important as the camera. In fact, it is as important as the camera. And so, you know, having that delicate and ability to adjust the lights really helps optimize the video that that this vehicle can take. So because we can take such beautiful, you know, because we have so many important aspects of filmmaking optimized and just so dialed in, we are able to take some really beautiful video of the seafloor and the animals that live there. So I'd like to show you some examples. Go on to the next one, please. This is a lion's mane jellyfish, and I just love the colors. It's we saw it in the deep ocean. I'm not sure where any of these came from, but they all came from the We Are the NOAA website, so you can find them online. So next, this is an anemone, and it looks like it's the same basic kind of animal that you see in tide pools on the shore of the ocean, and on the bottom, towards the left side, there's a close-up of part of its mouth that's where it takes in food. And then on the edges are beautiful polyps. So go next. And so this is a frogfish, and you can see the lure, you know, that dot between his eyes is actually a lure. He's called an ambush predator because, and a lot of the animals of the deep ocean, there's not a lot of food going down there, so they don't move a lot. And this guy doesn't move very much. He likes to sit on the ocean floor, and he uses that lure between his eyes to sort of catch the attention of animals that might be coming by. And when a shrimp or curious shrimp or fish gets too close, he'll just swallow them up with his mouth. And you can see really nice detail of his teeth and skin. All right, next. This is a Dumbo octopus. This is one of the cutest animals that you know, at least in my opinion. But he's also just fascinating in other ways. He's called the Dumbo because he has, you can see the flap in front of his, it's sort of coming from the side of the top bell. It sort of, he has one on each side, and they look a little bit like elephant ears. He uses them to help him fly. And this one's actually called a blind octopod because it doesn't have any retina in its eyes. Next. And this is just a nice picture of a coral on a rock. Corals really need a hard spot to live and grow. You won't ever find them growing on sediment because they really takes forever to grow. Some of them I'm not sure how old this one is, but some of the species of corals, especially in the deep ocean, can live to be thousands of years old. Next. And with that, I'd like to turn it over to Emily again to tell us a bit more about what the video team does on the ship.
Thanks, Tara. Yeah, so as Tara told us about some of the equipment and the lights that we use and when we're working on the Okeanos, and how that video content gets filmed by the ROVs and then is brought up to the ship, which is then distributed via satellite to the internet and the whole world. And so we are members of a video team, and so we're dedicated to you know, all the video work that's done on the ship. And so we have very discrete tasks that we have to do, and I'm going to go into some of those. So first of all is shading, which we went into a little bit before. Tara sort of talked about that shading position in the corner of the mission control room there. So this is another view of someone on the shading team. So the video shader is basically controlling the cameras on the ROVs from the ship. And some of the settings that we, can control is the white balance, the exposure, how bright or dark the image is, the focus, what on, in the scene that we're actually focusing on, and different zooms and stuff like that. So if you actually look at the photo here at each of these boxes, I see about 1, 2, 3, 4 boxes here. Each of those boxes controls a different camera. So when you're in the video shading position, you're often jumping from box to box to change the settings on different cameras, because we have, several, many, well, I actually don't know the exact number. We have several cameras on the ROVs, both on Sirius and on Deep Discoverer, and we end up consistently using about half a dozen of them. There are about 6 HD cameras between the ship and Deep Discoverer and Sirius that we really end up relying on. So an interesting aspect of the shader position is that you can't actually control pans or tilts. So like, if you're used to just using a camera on a tripod, you might want to like pan to like see different things on the horizon, or you might want to tilt the camera up and down. We actually don't have that ability at the shading position. That is actually controlled by the pilot and the co-pilot, who are controlling the ROV, both ROVs. And it's sort of, a setup that if you're, just out making a film or a documentary or shooting a commercial, you're used to being able to have full control over your own camera. But in this case, we need to work alongside the pilots to move those, to do those types of rotations, those types of movements of the camera. So it's a very interesting relationship, because when you're in the video shading chair, you have to have strong communication with the pilots. You can't just be changing the shot around willy-nilly without communicating with them, because they're relying on that video feed to have a sense of their surroundings, know if there's an obstacle or, a hazard that's in the way. So you're really working in very close tandem with the piloting team. So you need to have good communication about that. And another sort of interesting aspect of being a video shader is that we're collecting this footage for the sake of art in order to share it with the public and, share interesting videos and create beautiful and interesting videos, but it's also for science. NOAA's Office of Ocean Exploration and Research treats this video as data, and the scientists treat it as data, and it is used for, scientific research. The footage is analyzed by scientists for population counts of different species, for population records of different species at different locations and different depths. So you're creating a video product that is used both for art and for science. So it's a very interesting situation. Another one of our jobs is that we record the dives from start to finish. The dives are about 8 hours long, and we'll record it from the main camera on Deep Discoverer and on Sirius, on those 2 cameras. So this is a process that you need to, keep on track of. It's automated through some software, but we're always making sure that it's functioning properly. We also can clip out additional recordings from different other cameras that are on the vehicles as needed and as desired. And again, this is just another look at our control room. I went over the positions before, so you can just get a better sense of how all these different people serve very particular functions and how they all come together to, make the whole system work. So another important important task of the video team is creating daily highlight videos. They're usually about 30 to 90 seconds long, and it's just a fun way to show the coolest or the weirdest or the most important or the most awesome thing that we saw on the ROV dive that day. You never really know what you're going to see. There have been dives that the team has done where they were just going down to test the ROV and they stumbled upon a shipwreck. That's rare, that's not the rule, but it can happen. You can go down and see animals that you weren't expecting. You can go down and see geology that you weren't expecting. So these daily highlight videos are just great bite-sized ways to showcase what we saw that day. And they're really great for reaching out to the public, especially through social media. So I have some links that I included there. We were trying to test whether we could play some of these videos for you. Obviously with latency issues and internet speed, it ended up not quite working out. But if anyone watching wants to quickly write down those URLs, those are some links to some daily highlight videos that we've created. I'll give you a second to do that. And we also have long form videos. And these are more like 2 to 5 minutes long. And these are sort of, they explore bigger themes related to expedition as a whole and ocean exploration as a whole. Themes about, you know, technology, you know, international partnerships that we do in our work, conservation, things like that. And both the daily highlight videos and long form videos are, you know, they're shared with the public through NOAA's social media accounts. They're shared with educators who use them in classrooms and in learning environments. And they're also shared with policymakers. You know, we have representatives from NOAA OER who are going to Capitol Hill and talking with congressional staffers about why what we're doing is important. And, you know, there's so many products that come out of the work that's done on the Okeanos Explorer, but if you only have, you know, the attention of this congressman staffer for about 15 minutes, you know, one of the best ways to communicate them the value of what we do is to show them the videos we create. So the videos that we use are shared with policymakers and, you know, help to communicate the value of what we do. And there's some more links if you want to quickly jot those down. Again, apologize, we couldn't quite share the videos over Zoom. It just wasn't working with video speeds, but I highly recommend it. You know, they're just fun to watch because you'll just see amazing geology, amazing biology, again, from thousands of meters down on the ocean floor. We also grab still images. These are used in scientific reports that come out of the exploration work that we do on the ship, dive reports, research reports, species identifications, but they're again also used for social media. I think a lot of you attending this webinar might, you know, be on some of these social media accounts such as NOAA's Office of Ocean Exploration and Research or Global Foundation for Ocean Exploration social media. So you can see that, you know, the still images that we pull from the footage are very useful in that regard. And so here are just some more still images. This is an octopus that we saw. You know, seeing things like this can really reach out to the public to show them, like, this is what we're seeing on the bottom of the ocean. And for example, here's a still image of a massive coral tree. We measured the base of that coral tree. It was something between 15 and 20 centimeters thick. It's just these massive coral communities that we can find in certain cases. And we like sharing those with the public in still images. And then last but not least, in terms of the tasks that we have on the video team, on the ship, when we're, you know, not doing the shading or doing the clipping or pulling out still images or editing videos, we're taking what we call topside photos, and that's photos of life on the ship. These are photos not taken with the cameras on the ROV, but taken with our own digital cameras, our own film team equipment. And so we might catch sunrise, you know, before launch while the engineers are examining the equipment, you know, and or photos of personnel on the ship. And a lot of these photos are used again by NOAA OER in web posts, in daily briefings, in public-facing weblogs on their website and on their social media pages. So it's just footage of life on the ship, of the operations on the ship, taken with our team's own digital cameras. And so that's what we do. Those are our tasks. And then occasionally when we're done, we sleep. So, so just to quickly wrap up about that, you know, if you are interested in this line of work, I have to say there's a lot of learning on the job. You end up learning a lot about video engineering too, because we work with such highly technical, highly specialized equipment and software. And, you know, if you're out in the middle of the ocean and we have, you know, limited bandwidth of internet that, you know, we have for us to use, it means like you need to troubleshoot stuff on your own. It doesn't mean you can necessarily like call tech support, you know, that's in 8 hours in a different time zone to figure out how this thing works. You need to figure out how it works on your own. That being said, it's incredibly educational, incredibly supportive environment. And I've learned so much just from the 4 years I've been working on the ship. And with that, I'm going to pass it on to Caitlin, who's going to talk a bit more about the video team and what we do when we're not on the Okeanos.
Yeah, so we're not like always like working at sea. We actually do a lot of work like from like shore too. Like we like edit videos for other like GFOE projects. We're also like always like looking at new like technologies too. And like we're for like example, like we're like really excited like to be adding a 360 VR camera to our other ROV Yogi, which is going to be on a NOAA sanctuaries cruise, looking at shipwrecks in the Atlantic in August. And so like, you know, as like independent filmmakers, like we're like always like learning like new skills. And so now I actually want to like talk with you about something that I've been like working on like learning over the past year. I've been learning and like practicing like what like you would think of as like a traditional like underwater filmmaking. Go to the next slide, please. Because, you know, I mean, like not like everybody has access to like a like nearly 10,000 pound like ROV, like all the like time and stuff. And so as a filmmaker, one of my like life goals was to film leopard seals underwater in Antarctica. So I had researched and trained all of last year, and a couple of months ago in February, I actually achieved my goal and filmed a leopard seal underwater. Next slide. I still have a lot to I still have a lot to like learn, and of course like I also want like to go back to like film like more like leopard seals and like ice and stuff. But I also want to share a little bit of what I like learned about underwater filmmaking like over the past year like with you, and you know maybe give a little bit of like advice, you know, if you're looking at like getting like your own like underwater camera. We're not endorsing or like recommending any particular brands, so like these are just some like examples. So first of all, if you're just starting out, next slide. If you're just starting out, like you like really don't need to like invest in a large like setup like right away. In fact, starting off like with your smartphone or an action camera like a GoPro are actually great ways to practice. They're small, you know, are like handheld, and really like actually make like pretty decent video. And so like these are great options for any getting like early career or you know, like recreational divers. I mean, like, I actually love like my like GoPro like a lot and stuff. So I actually film like with it like quite often. Next slide though, but if you want to like invest in a digital camera but don't want to quite get into like the like DSLRs yet, or like mirrorless camera yet, there are like some like underwater point and shoot cameras like that are also great too. I actually know of like filmmakers that like will like have them like in their like pocket of their like dry suit or like BCD, and will like just like whip it out like for like a quick like photo and stuff. Now on our next slide, DSLR and like DSLR and mirrorless cameras are also great options if you have a little bit of a higher budget. I actually invested in a mirrorless camera myself because I knew that I would also film like with it on land, and the housing for the like camera was actually smaller and cheaper than the like one like that I would have gotten for like my like main like DSLR. And so like that's like the like path that I had like picked. On the next slide though, that's kind of the like cinematic cameras are the like next level for like those who are shooting like big like budget projects. These cameras can like capture amazing 8K or even like large like format video, like that IMAX camera on the like right there. I don't think any recreational divers will be like investing in like one of these, but filmmakers like who are ready for it like might like use like something like this. And if you really love like the ocean but like really don't like want like to get wet, there are like underwater drones too for you, do underwater filmmaking, but like from like a boat or like shore and stuff. So but some things that totally consider like when you're like looking at getting a camera, is the investment and your budget. Do you really want to go like this route in like your like career, or should you try like maybe like renting or like borrowing a like setup first? Because it's not just the camera and housing that like you'll be like investing in, but it's everything else like that like comes like with it too, like lights. So again, like Emily and like Tara like mentioned earlier, that like lights are like extremely like important, especially in like deeper areas, where like there like may not be like lots of like natural light. The type of shooting that like you do too like will it also like determine what kind of like lens you invest in. So if you shoot macro, so like tiny things, the like your like dome like will be different than like somebody who shoots like wide angle. And like if you're shooting macro, like you like might like also want to like get, you might also want to get a tripod too, and so, you know, like that like type of shooting like that, like you're like aiming for like really, you know, like determines like what kind of gear like that you get. And like once you have a lens on your camera, you can't change it on change it underwater. And so it can be really difficult to like decide like what kind of lens like you like want, because if you go diving on a spot and want to focus on like nudibranchs and are shooting like macro, but then a whale shark comes by, you know, it's, you know, like you might like miss out on it. So it's a give and take, you know. But you know, like all of this gear though is heavy. So maybe if you don't want to travel like with a housing, yeah, and like accessories, you know, like maybe, yeah, like maybe just like a small like camera is actually like better like for you. But you know, next slide, please. But definitely research and like ask like other people for like advice. But in the end, do like what's best for you and like your like interests. Like what like do you want to 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 film. So, and before like you like film like anything underwater though, you have to be comfortable in the water, like whether like you're like snorkeling or like scuba diving. So the more like comfortable and like confident that like you are in the water, the better like your shots like will be. So, but either way, like in the end, whether you are working on a ship or like swimming with the fish, like you have to have fun. And like underwater filmmaking opens you to a whole new world. Next slide. And it's amazing like when you share it with other people, and seeing new animal behaviors is probably one of my favorite things about like underwater filmmaking. You know, like whether it's a leopard seal like getting like right like in like your like face, or seeing a shrimp eat a fish and stuff. So it's a lot of fun, and I love like working with like these like people and like animals. Tara, like Emily, like what about you guys?
Well, my favorite thing, you know, besides seeing discoveries happen live, is I think my favorite thing is the stars, because there are no better stars than when you're at sea. You're so far from the nearest city that it's pitch black, and so I was dumbfounded the first time I was on the ocean, because there were so many stars you couldn't even find the constellations that you're used to seeing. And the Milky Way was this huge swath of bright light across the sky. So that's what I love. And also sometimes if you're lucky on a good night, you'll see not only stars above, but stars below, especially if you go out on the bow. Sometimes we'll be in areas where there's all these organisms in the water that will glow when they're disturbed. And so when the bow goes through them, they'll start glowing on either side. So it's especially wonderful when you have stars above and stars below.
Yeah, I'd have to say one of my favorite things about being an underwater filmmaker on the Okeanos is, you know, seeing parts of the planet, seeing parts of the ocean that no humans have ever seen before. We can very confidently say when we go down with the ROV onto a new site that we are seeing a part of this earth that human eyes have never seen before. And we see just such amazing life down there. The animal life, the corals, the fish, the crabs, the you know, sharks, crustaceans, everything down there. It's just so diverse and so beautiful and so unique. And we get to share it with the world. So, well, so thank you, everybody. We also have with us Melissa Ryan. She's the Vice President of Global Foundation for Ocean Exploration, and she's gonna help us. We're gonna do a bit of a Q&A, and she's gonna help us curate some of those questions that you have for us, and we're gonna do our best job to try and answer them.
Sounds good. Hi, everybody. This is Melissa. You should have a question box in your panel, probably on the side of your screen. We don't see quite what you're seeing, but so if you have questions, please feel free to type them in and we'll get to them. We did have two come in through the chat box, and they're from young students. So the first one is, do the ROVs and cameras, or are the ROVs and cameras a curiosity to ocean life, or does it make them react in a different way?
It depends on the life, really. Some of them, sometimes some fish will we think that some of the larger animals, like larger fish, they can sometimes swim away because we don't see as many of those. But a lot of times they're just curious, or just, trying to figure out what in the world could that be. I had something I was going to say, but it just slipped my mind. So anybody else have had more to add to that?
Yeah, I think we've seen sort of a range of behaviors. Like, I remember just like once or twice you see animals that seem like actively curious and, just like to check out the vehicle. One animal that particularly likes to hang out around the vehicles are squid. In certain areas where there's high volumes of squid, we'll just get swarms of squid that hang out around our vehicle. And it's actually because there's smaller animals like shrimp and crustaceans that are attracted to our lights. So we get all these planktonic animals that are attracted to our lights, and then the squid just descend on the vehicle to hunt the little planktonic animals that are aggregating on the vehicle. But for the most part, most animals just ignore it, from what I can say.
Okay. Another question from the same students is, if the lights are on the vehicles, does it make the bioluminescent fish change?
Yes. So, well, the ones on the surface that I was just talking about, you can't see them with lights because they're very faint. So if we turn on the lights, or when it's daytime, you can't see them at all. But in the deep ocean, and same story probably in the deep ocean, we generally have pretty bright ROV lights. So we've tried a couple times turning off lights, but our cameras probably aren't sensitive enough to see them because we haven't seen a ton of glowing. But so there are some animals that you can still see a bit of a glow. So what comes to mind is a ctenophore. They don't really bioluminesce though. They have a cilia, rows of hair-like cilia that move in concert with each other. So it ends up looking like a moving neon lights, but it's just a reflection. So that's the only animal that I can think of that I see, that seems like it's glowing.
So we may actually have an answer for you, a better answer for you on that.
Oh, great.
One of the things that we're working on here at Global Foundation is a see in the dark camera. We're partnering with Canon, and we're going to hopefully get that to go down to the 6,000 meter depth rating. And so basically there's just a tiny, tiny, tiny amount of light. And so we'll have a better idea of how the animals actually react when there's not lights shining at them. So coming soon, stay tuned for that one. Okay, so we have a couple questions coming in. What is the most unusual creature you have filmed? You're thinking hard.
It's hard to choose one. Let's see.
It's so funny because after filming these animals for for 4 years, you know, like they're not weird like anymore. You know, like they're kind of just normal animals now. So, but I mean, I think, you know, like filming like interesting like behaviors though is really cool. Or actually a couple of, or I think last year or something, I forget which expedition it was like we actually found something that I'd never heard of before. We actually filmed a shark embryo in its egg case, but like the egg case was actually transparent, and so we could see this like baby shark moving inside of its egg cage. And I've, you know, like as an animal biologist and stuff, I'd never heard of that ever, and I was like freaking out, like so excited and stuff like that. Like I wanted us like to like stay like with it till it hatched, you know, which you know, like who knows like how long like that would have been. But that was so, you know, unusual with with an animal that, you know, it's like pretty common. So
yeah, that baby shark inside the egg case, like basically that had yet to be born, but seeing it, because the egg cases, if you shine light up to them, they're like partially see-through, so you can see the shark inside moving around. That was pretty incredible. That's an excellent, I just remembered that now. Thank you for reminding me that of that, Caitlin. In terms of most unusual creature, I got a kick out of the giant isopod, also known as Bathynomus giganteus, I think. Maybe double check that.
Yeah.
Where if, I don't know, like depending on where you live, I grew up on the East Coast. If you dug into the dirt, you found like these little pill bugs or roly-polies. Well, those exist in the ocean, but they're about a foot long. So if you dig up roly-polies in the dirt in your backyard and they're like about 2 millimeters long, well, they're ones that exist like that are like a foot long, and they just seem like something from a science fiction movie. It's just crazy. So it's just a giant isopod is what it's called, actually. So that was pretty neat. I recommend you do an internet search of deep sea giant isopod, and that'll blow your mind for a day, I'd say.
Okay. In the interest of, oh, sorry, Tara. In the interest of time, because we only have about 8 minutes left, and we've got a bunch of questions, which is great.
Sounds good. We can move on.
So if you don't mind, I'll move on to those. Okay. Do any of you have experience using infrared or red light to observe habitat, marine life, as opposed to white light?
No. Melissa, is the new low light camera gonna employ that kind of technology?
Yes, it is. It absolutely is, and that's why it's
technology for us is just getting there then.
Yeah. So I don't think we do yet.
I look forward to it.
Okay, another question. With the Zeus camera, do you use something on the ROV to white balance on the bottom? If so, how often do you perform this task? Who would like that one?
Well, we do it once a dive, at the beginning of the dive, and we always wait at least an hour if we can. We do it right before we get to the bottom, because that gives, when the bottle temperature on the ROV, all the electronics are in a bottle, and that temperature has to decrease to about the dive temperature it's going to be at for the rest of the dive. And so we wait until that's cooled down, because that gives us the most accurate white balance. And then this is, Melissa brought up this slide, and that's the white balance color chart and grayscale chart that we use. And so it's a little bit complicated, but first we zoom in on the gray part only, and then we do our, we white balance the black, the black and white part of the camera. And then we zoom out and have the colors and balance the colors on the camera. And there are a couple of waveform sort of scopes that we can watch to do that. And then we just try and get the colors as close to where they should be, as close as accurate as possible. So, and we do that on the main camera and the secondary camera on D2.
Great, thanks, Tara.
Mm-hmm.
Okay, and one more question. Do you also use the footage for storytelling purposes? For example, mini documentaries about life on the ship or specific species?
Absolutely. So as I mentioned before, yeah, the short and long videos, the daily highlight videos and the long form videos that we do, we partner with NOAA OER, and they're very public facing. You know, they want the world to know what we're seeing. And part of our job is to help do that. And so if you go to GFOE's website, Engineering for Discovery, if you go to NOAA OER's website, I believe it's oceanexplorer.noaa.gov, you'll see over the past few years, just probably up into the hundreds now, videos about specific species, yes, videos about life on the ship. I know Caitlin in particular did a ship tour video that was just showed all the different aspects of ship life, you know, everything from the bridge where the crew actually drive the ship itself, all the way down to the mess and the team that helps feed the 40-person crew 3 times a day. So there's lots of mini documentaries. Also, this footage is public domain. It's a government entity. And so if you really want it, anyone in the world can take this public domain footage and use it to create documentaries themselves.
Great. Okay, does anyone else have any questions quickly before we wrap up here? Give you a second if you want to type. Okay, it looks like that's it. Thank you all.
Yes,
Thanks to our
thank you.
panelists and everybody who joined. This is our first in our webinar series that we're trying to get out there just to help out those parents and students and everybody who's looking for cool stuff to do online. I know there's a lot of it out there, but we're doing a webinar next Thursday at noontime Eastern Standard, and that one is going to be about a shipwreck search for a famous Revolutionary War ship. So you can register by going to, we'll have it on our Facebook page pretty soon, probably tomorrow, so watch for that. And thanks to everybody.
Yes, thank you so much for joining us.
Mm-hmm.
Thank you so much. We really appreciate everyone taking the time to come out and hear about what we do.
For sure. Appreciate it.
Bye-bye.